On this section, we are going to study the work done by a spring, by the force that making a spring on a body of mass m, and we are going to define that the force done by the spring is minus kx by I. Is on the direction of I, and the value is minus kx. What does it mean this? It means like this. If you are in an x that is positive, the value of the force is negative. So if x is positive, the value of the fx is negative, and if x is negative, the force is positive. So for x positive, the force is negative. For x negative, the force is positive. So the force acting like a central force is a force that always takes you to the origin. If you are here, let's say you are here, the force will take you with a big force because it's proportional to the distance to the negative. If you are here, the force will take you to this, to the origin also. Always is it's an attractive force. It always attracts the body to the center. So we want to find the potential energy. You want to find first the work associated with this force. Also, we want to find the potential energy associated with this force. So let's go to change the force for the force plus kxi. And let's go to calculate the force on this one. How we will calculate the work done from going from x1 to x2? Well, I have shown you the method. We divide the delta x with delta x. We divide in a small delta x, very small delta x, and we calculate the work done, fx by delta x, and this is the small delta work done, and we sum of the works done here, and this is the area. So in going to make the work from x1 to x2, let's go to calculate the area that is below the curve. So let's go to prove that the work done for this force is kx2 squared divided by 2 minus kx1 squared divided by 2. So we want to prove this. So the method to calculate that the work is from x1 to x2 is what I said, is this expression is just to calculate the area. A1 and A2. A1 is the area of a rectangle. The size is delta x here, and the height is f of x1. And the area of the triangle, is 1/2 of the base, that is delta x, by the height. But the height is f of x2 minus f of x1. F of x2 is everything. F of x1 is this, so f of x2 minus f of x1 is the height. So if you calculate, you can prove it. It's easy to prove it, and you can find this result. So make this problem. I will give you 200 points to review everything and to tell me if this is correct. Okay, 200 points. Well, if f is equal minus kx, the force in going from x1 to x2 will be 1/2 of kx1 squared minus x2 squared, because it's a chain of sign for this force. We have obtained the work for the force positive. Now if we obtain the work for the force that is negative, we will obtain the negative result that we have obtained. So this is the work done from x1 to x2 by this force, minus kxi. So if the work depends on the initial position and final position, we know that the force is conservative. So if the force is conservative, we can associate a potential energy. And how we can associate a potential energy? We say that the work from going to x1 to x2 is minus the variation of the potential. So it's A sub p of x1 minus E sub p of x2. So in our case, the work is minus kx, and the potential energy that will match this equation will be 1/2 kx1 squared. plus C, because if I take this quantity minus this quantity will be the work. So this is the potential energy. The potential energy is 1/2 kx squared. So the function 1/2 ax squared is the potential energy of the spring. We have found what is the work done by a spring in going to x1 to x2, and we have found this is the work by the spring, and we have found that the potential energy associated with the spring is 1/2 kx squared. Okay, I'm not going to put any homework for this part, not yet.